Example 1, limit as x approaches 0, 1 minus cos x divided by x squared. You check whether you can use direct method to solve this limit by putting the value of x to be 0. So it will be 1 minus cos 0, that is 1 minus 1. Cos 0 is 1, 1 minus 1 is 0, divided by 0. So 0 divided by 0, this is non-determinate form. Now, if your limit is in non-determinate form, you make it determinate by using L'Hospital's rule. And L'Hospital's rule states that limit of x approaches 0, f of x divided by gx is equivalent to limit as x approaches 0. You find derivative of numerator side with the denominator side separately. Note that we are not using the quotient rule. You find numerator separately and the denominator separately. So your limit is non-determinate. You make it to be determinate by differentiating the numerator and the denominator separately. So it will be limit as x approaches 0. Derivative of 1 automatically is 0. And derivative of cos x is minus sin x. Minus and minus cancel. So sin x divide 2x. So you try whether it is determinate or non-determinate. You equate for x to be 0. You have 0 divided by 0. If you have differentiated the first time and you found that it is non-determinate, you now differentiate for the second time. So you differentiate numerator second times and denominator second time. So it will be limit as x approaches 0. Derivative of sin x is cos x, and the derivative of 2x is 2, which is equivalent to cos 0 is 1 divided by 2. Your required answer. Example 2, limit as x approaches 0, e raised to the power x divided by x. First of all, you check whether your solution is indeterminate or non-determinate form. So e raised to the power 0 is 1, and 1 divided by 0 is, so you check e raised to the power 0 divided by 0. So this is, any number raised to the power 0 automatically is 1. 1 divided by 0, which is equivalent to infinity. Oh, that one was so simple. Your answer is infinity. Infinity. 1 over 0 is indeterminate form. Directly, that is your required solution. 3, limit as x approaches 0, sin x raised to the power ln of x. So as usual, you check whether the solution, when you put the value of x to be 0, is determinate or non-determinate. So limit sin of 0 is 0. So 0 raised to the power 1 over 0 raised to the power infinity. This is non-determinate. So it will be suitable if we use L'Hospital's rule in form of, so your question is in form of limit x approaches 0, f of x raised to the power gx, which now you use L'Hospital's rule, which will be in form of e exponential raised to the power limit x approaches 0 multiplied by gx natural log of f of x. So now you write this in this form now using L'Hospital's rule. It will be limit, you ignore exponential, you will come to use it after solving this part. Read together. So limit x approaches 0, g of x is this 1 divided by ln of x multiplied by natural log of f of x, natural log of sin x, like that. So you check whether this will give you the required solution. Natural log of sin x divided by natural log of x. Put the value of x to be 0. Natural log of sin x, sin 0 is 0. Natural log of 0 is 0, isn't 0 divided by 0. This again is in non-determinate form. You make it determinate by differentiating numerator and denominator separately. So it will be limit x approaches 0. So you differentiate numerator part. So natural log of sin x. You find derivative of sin x, which is cos x divided by sin x. That is that part. You have differentiated the numerator part. Divide by 1 over x. So you put x there. Again, you have that. You have differentiated for the first time to try to make it determinate. Try to make the solution to be determinate. So you have x cos x divided by sin x. So you check. So for putting the value of x to be 0, it will be 0 divided by 0. Again, this is in non-determinate form. You make it determinate. Okay, you make it determinate by differentiating again. So this is non-determinate. You differentiate separately numerator and denominator. It will be limit x approaches 0. So you have two fractions on numerator side. You use product rule. You find derivative of x, you hold the cos. Then plus you find derivative of cos, you hold the x. So it will be cos x minus x sin x. Find the derivative of sin is cos x. Which is equivalent to, you separate, x approaches 0. Cos x divided by cos x is 1 minus limit x approaches 0. X sin x divided by cos x. Directly, this is 1 minus 0. So your answer is 1. But we left that exponential e raised to the power 1, which is equivalent to 2. That is your required solution.